All right, Remzel staff. Hopefully, I challenged your brains in a good way with this and not in the bad way. Although, hopefully, you will maybe get some hints during this video and then be able to pause the video and see if you can finish the rest of the problem with just the hints. And if you can't, then just come back to it and see if that helps you. Okay, so first thing I wanted to start with here, now that I got my pin to the right size, is the fact that we know that each one of these rectangles has an area of 4, which is a super useful thing to start off with just because it gets us thinking about what is the area of a rectangle. Well, you might have looked it up or you might have just remembered it, but the area of a rectangle is just the base times the height of that rectangle. And we also, from this, know that, well, the area of this rectangle is 4, the area of this rectangle is 4, the area of this rectangle is 4. So if there was none of this overlap, then the total area of all 3 rectangles would have been 12. And then to get the area shown by this shape, all we would have to do is subtract the amount of overlap that we get. Oops. So 12 minus the overlap. This is ultimately what we're looking for right off the bat. Okay, now that we know that, let's use the classic algebra technique. And I think this is also the hint for some of you that might be helpful, or maybe it's not, I don't know. Let's call the side lengths of this rectangle variables. So we're going to use x and y because that's what we typically use in algebra. And let's call the short side length x and the long side length y. The reason that that could be super valuable for us is because we know that the black dots mark the midpoints of the short sides. So I don't know how long the short side is, but if I call it x, I know that this side length is half of that, x over 2. The other important point here is that if I call the long side y, I don't know how long that is, but I know that this part of it is y over 2. Now, this is an important point just because I did not state that the center point is the midpoint of all of these rectangles, the long side of all of these rectangles. However, you can tell just visually that that's what the case is, that all of these rectangles do intersect there. But if you were to do a little bit of geometric proof, you would find that there's no other way this shape could come together either. It has to be the midpoint of the long side as well. So that leaves us with just, okay, well, how do I find what is the area of this shape? Well, some of you may have said, well, what is this shape? I'm just going to look it up on Google. And you might have said, well, it looks like a diamond, or maybe you remembered from way back in the day, oh, I think this is called a rhombus. But looked it up on the resource of Google. Part of the reason I'm bringing it up is just because the resource of Google can be a challenge to deal with. And so I wanted to highlight some of the things that are a bit challenging about that. I think the most challenging part in this case is if you looked up on Google, and I just chose this page just because I assume a lot of people, if they looked up what's the area of a diamond or of a rhombus, you probably got to the WikiHow page. And what this page says is that there are 3 ways that we could find the area of a rhombus. The first way that they give us is to use the diagonals. So that might have brought you back to your diagram. You might have started trying to calculate what are the lengths of some of these diagonals here. But you would have realized that very quickly that becomes a major challenge. Something that I would point you to instead is if you scroll down to the second method for finding the area of a rhombus, it's to just use the base and height. But the reason that I think Google can sometimes be a bit tricky is because this particular example is one that, yeah, we have the base, but we actually don't know what the height is because it's not one of these side lengths, right? So this 7 goes through the direct center of this rhombus. We would have had to calculate what that size is on our shape, right? We could have used this y over 2 as the base, but then we would have to figure out what is the height here. Well, that is where, if you were trying to figure out what that height would have been, you might have noticed that we don't have the same scenario of rhombus as was shown on Google, right? We have a right angle there. And I'm going to try to convince you that this is a right angle in two ways. The first way is just check out this other rhombus down here, right? We can see pretty visually that this corner has to be a right angle. And the proof for that I think you could extend to this rhombus that's not on that same kind of 0 degree, 90 degree plane that lets us see very easily it's a right angle, is because this is the corner of a green rectangle, right? And the same thing is true over here. This side is the corner, the 90 degree corner of the blue rectangle. This side is the 90 degree corner of the pink rectangle. So it turns out that we actually do already have the base and the height of this particular rhombus. We can just use that to calculate the area for this one, right? So at this point, I'm not even going to go back to our WikiHow to try to figure out what the last method for determining the area of a rhombus is. I'm just going to use what we have, because we know that in this case, our base is a value of x over 2 times our height is a value of y over 2. When we multiply fractions, we just multiply straight across. So this is x times y. In algebraic terms, abbreviated as just xy. We don't even need the multiplication symbol in the middle there. And we're going to multiply the denominator straight across as well over 4. Now, all I need to do is multiply this area times 3, because there's 3 of these, right? This is an area of xy over 4. This is an area of xy over 4, and same here. So if I just multiply xy over 4 times 3, and then do 12 minus that value, I should have the total area that I need. One last point that I think many of you at this point have probably already connected is the fact that the area of each of these rectangles is 4, meaning x times y is equal to 4. So when we have xy over 4 as our area, what we're actually saying is 4 over 4, which is 1. That means that the area of each of these is 1, and that means that if we were to plug that into our equation, 12 minus 3 times 1 for each one of these overlapping areas, then our final answer for this is that the area of the entire shape is 9.